Hi everyone and welcome to MathSux. This video is going to help you pass statistics. In this video we're going to go over the z-table and normal distribution by identifying what a normal curve is, the z-score formula, and how to find probability using z-score. So we're going to start with the normal curve here. So all the normal curve is a bell-shaped curve that shows the distribution of data that is evenly spread where the mean is in the middle. So everything is in relation to the mean. So if you notice, we have this line going down the middle, and we have this Greek letter mu that represents the mean. So notice that half the data is above the mean and half the data is below the mean, and they're symmetric about each other with respect to the mean, which is in the middle. So the way we measure the distance from the mean is by using the standard deviation, which is notated with the Greek letter sigma. So that's what this Greek letter is, the standard deviation. And this is a unique unit of measurement that is unique to each data set. So when we're going one standard deviation above the mean, we're going mu plus sigma. And then two standard deviations above the mean is mu plus 2 sigma. And the same way works going down. So mu minus sigma is going down one standard deviation and then going down 2 standard deviations to mu minus 2 sigma. So everything is in respect to the mean and symmetrical. So the great thing about normal distributions is that since everything is evenly spaced, we can find the probability really easily. So under the curve represents, all the space under the curve represents the probability of each data point occurring. So let's say a data point occurs here. What is the probability of that occurring? And we can find that using z-score. So z-score can tell us what percentile a certain point in the data set falls in relation to the rest of the mean. So let's write out what each part of this formula says. So we have z, that's our z-score, is equal to x. So this is just some data point. So whatever data point you're asking for, like temperatures or test scores, something like that. And then this is again mu, our mean, our average. And then sigma, we have here again, is the standard deviation. So just based on this formula, you could see that we're looking at the data's distance to the mean and then dividing by the standard deviation, that unique unit of measurement, to find z-score. So we're going to look at an example. It has a couple of different parts to it. It says SAT scores for the math section are normally distributed with a mean of 500 and a standard deviation of 100. A, what percent of students scored below 500? B, what percent of students scored above 620? And C, what is the highest score a student could receive if the student was in the 16.11th percentile? So we're going to do this one step at a time. So let's look at A, what percent of students scored below 500? So right away, what I want to do when I see that these scores are normally distributed, we know we're going to have a normal curve. We know the mean, or the mu, is going to be equal to 500. And the standard deviation is 100. So the sigma is 100. So that unique unit of measurement, we're going to be going up by 100 and down by 100. So let's just draw out our curve. So remember, the mean always goes in the middle. So this is equal to 500. And now if we wanted to see one standard deviation above the mean, our standard deviation is 100. So we're just going to be adding 100 here, which gives us 600. And then two standard deviations would be plus another 100, which gives us 700. And if we wanted to go a third standard deviation up, plus another 100, this gives us 800. And we're also going to go the other way. So 500 minus 100 is 400, minus that one standard deviation. And if we do this minus 2 standard deviations, this gives us 300 and then 200. So you could see how we're going up to the right and down to the left. So they want to know what percent of students scored below a 500. So this is where drawing these curves really come in handy, because we want to visualize what percent of students scored below a 500. So we know 500 happens to be the mean. So we want to know the probability, the percentage of students that scored below 500. So everything less than 500. So everything to the left of this mean in the bell curve. So you can see right away that this is going to be 50%. So you can just kind of eyeball this question, but we're going to do it the long way also. So we're going to look at z-score also. So remember our z-score formula is equal to x minus mu all over sigma. So our x, our data point, is 500, which happens to be the same as our mu, our mean, which is also 500, all over the standard deviation, the sigma, 100. So you can see right away our z-score is going to equal 0, right? So what do we do with this? We're going to take out our z-table. So if you look at our z-table, the picture, this is a reference table, so on a test or something you're always going to have this. So if you notice the reference, on the reference table itself, the bell curve is shaded just like ours. So we know that the answers shown within this table will show the probability of shading from starting at the left going to the right. So we know that this is the right table to look at, and we're good. And what we're going to be looking at is our z-score. So the way to do that is just to look on the left and look for 0. So since we got 0, 0, this is really 0.0. And that's how this works. So on the left, you're always looking for the 10th, the z-score. This is a z, the little light. And then over here is the 100th decimal. So if it was this was like 0.01, we would end up over here. But this question has 0.00. So we know that this is our answer, 0.5, so or 50%. So z is equal to 0.5123, and when you multiply this times 100, this is just going to be 50%. And that's our answer. So now on to the second part, part B, what percent of students scored above 620? So we're going to start the same exact way. Let's draw a bell curve with all that information we know. So we know the mean is 500, so we could just write this in. The standard deviation is 100, so that means we're going to go up by 100 and then down by 100 on the other side. So let's just mark that this is our mean, so we don't forget that. That's our center point. And what are we looking for? We want to know what percent of students scored above a 620. So the last question was easier because it was just 500, but 620, that's in the middle of these standard deviations. So let's mark about where that might be. So right here is maybe about 620. That's the data point we want. And we want to know what percent of students scored above 620. So we want to go this way this time. We want to know the probability in this section of the bell curve. So let's write out our z-score formula again. So we have z is equal to x minus mu all over sigma. So our data point this time is equal to 620, because that's the score we're looking for. Everything above that. Minus mu, the mean, 500, all over sigma, standard deviation 100. So when we calculate this, we end up getting 1.2. So when we look back at our table, now we know we're going to be looking for 1.2. But remember, when we look at our bell curve, the reference bell curve, we see here that we're getting all this space. But we kind of want the opposite of that, right? So we know, we can plan ahead. We know that whatever z-score we get, we're going to be subtracting it for 1, because everything under the bell curve altogether will equal 1 or 100%. We're preparing ourselves, so we're going to subtract everything from 1 because we want the opposite. So now, when we look for 1.2, we're going to go down here. So we have 1.2, 0, because we don't have any other decimals after that. And we get this value right here, 0.8849. So it's going to be 1 minus 0.8849. So when we plug that into the calculator, we're going to get 0.1151, and we can multiply this times 100 to get that percent, which will just give us 11.51%. So the answer we found tells us that 11.51% of students scored above a 620. So now for the last part of our question, we have C. What is the highest score a student can receive if the student was in the 16.11th percentile? So this This is a little different than the other two. This one we kind of have to work backwards. So instead of giving us the score, the data point, we have to find it, and they give us the percentile. So to do that, we're gonna have to work a little backwards and start with the table this time. So first, let's write out our formula and the things we do know. So we know we're gonna be looking for z-score on the table, and then we're gonna be finding x this time because we don't know, that's that data point we don't know yet, that test score, minus mu, which has been 500 this whole time, divided by the standard deviation, the sigma, which is 100. So now let's look at that table, and we want to look at the decimal points for something that looks like 16.11. So everything here looks pretty high. So let's look at the negative values and look for 16.1. So we found it right here, and notice that it lines up with minus 0.9. So the 100th point is 9 also. So it ends up being minus 0.99 if you look at the cross section here. So if we highlight this, you could see that we have minus 0.99. So knowing that, we can now fill in, this is the z-score. So we can now fill in this z-score. Minus 0.99 is equal to x minus 500 divided by 100. And now we just have like this normal, easy algebra problem. So we could cross multiply, and we're going to get negative 99 is equal to x minus 500. And then we're going to add 500 to both sides. And we end up with 401 is equal to x, which is our answer. So this highest score a student could receive if the student was in the 16.11 percentile is 401. So that is our answer. So just to be clear about what that means, if we draw out our bell curve that we've been drawing this whole time, and the mu is 500, and we go down 100 with the standard deviation, and then up on the other side by 100. So what that means for 0.401, which is about here, so basically we're trying to find the highest point possible that's included in this percentile. So this is just kind of a backwards way of asking that, but these are the kinds of questions you got to be aware of when you're taking statistics. So if you're looking for more, check out my website, MathSux.org, for practice questions. And if you're looking to make math suck just a little bit less, think about subscribing to my YouTube channel. I post free math videos every week with lessons, and thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!